When I talked about test as a noun and test as a verb, the implication is that we're talking about a test and running tests. But there's a lot more to testing than creating and running tests. In this video, I want to talk about testing. So I'm suggesting that testing is much more than just creating tests and running them. Some time ago I created a model of how I believe testers think when we test. So it's called the new model for testing. It's not so new, but it might be new to you. Anyway, that model will get its own video a bit later in the series, I hope. Now the model identifies specific ways of thinking, modes of thought, if you like, and each thought has associated real-world activities. So it's kind of an abstraction, of course. But for now, I'm just going to use some of the thinking in the new model to walk you through some of the activities of testing to show how broad an activity testing actually is. Now I'm going to start by, if you like, giving you the message from the mountaintop, let's say, and make this suggestion that all testing is exploratory. And let me just expand on that a little bit. What we do is we explore sources of knowledge, sources of information, and we use those sources of information to build mental models, to build our understanding. And when we have a mental model, an understanding that we think is adequate, we use that model to inform our testing, to help us select things to cover in testing. Now, there are multiple sources of knowledge in every project. It's not just about user stories or requirements or whatever. Of course, we might have requirements in the form of a narrative text document, a long-winded, many-page document. But we might have user stories, we might have use cases, we might have other models and diagrams to describe user behavior and requirements. But we also have the people on our team who are a source of knowledge. Of course, with a user story, they might be very summary and actual knowledge is communicated verbally or maybe stood in front of a whiteboard. But the people in our team are obviously a source of knowledge. There are documentation in many forms that might be helpful to us, models perhaps if we're lucky. The old system is a source of knowledge because if we're replacing an old system, obviously some of the behaviour of the old system we want to replicate in the new one. Other functionality we might want to build from scratch or restart. Of course, the new system itself is a source of knowledge when it's available. Now also there's what's inside our heads. That informs our behaviour as testers. So our knowledge and experience, but also our biases and prejudices influence how we understand requirements, how we interpret what the system should do and what it actually does do. Now all of these sources of knowledge are fallible. They're all sourced ultimately from human beings who make mistakes. So if you like, what the tester has to do is to make a judgment as to the sources that are most reliable, accurate, consistent, and so on. Now, as we learn what a system should do, or actually does do, we build our mental models, as we go along. And those mental models reflect our understanding. Why do we build models? Well, models help us to assimilate complexity. And what models do is they represent the things of significance to us at that moment in time, whatever we're trying to do. And we use those models to, if you like, capture that knowledge, to describe that knowledge in some way. Now, we might write the models down. We might not. We might just keep them in our heads and that's an end to it. But the models are inevitable. I mean, you might not realize you're building mental models, but you are all the time. Now, we might be given models occasionally by people in our project. So an architecture diagram might help us to understand the technology under the bonnet, if you like. Or use cases or user journeys might help us understand how the users are going to behave in using the system to do whatever they want to do. So our mental model is our understanding, and you could use that very word, model, and substitute it with the word understanding. Our models are our understanding. Now, as we learn more, we encounter anomalies in our sources of knowledge. We see gaps, we see contradictions, we might see ambiguity, and usually we'll have a word with our users to better understand what these requirements actually mean and maybe to correct them too. But at some point, we learn enough and we think we know enough, we understand enough, our model is ready, we can start thinking more seriously about testing. So when we explore, we're learning, building models, and as we become confident our model is reasonable, we start using that to critique the system in ways that are going to be helpful to our stakeholders. We're ready to test when we have a mental model. Our coverage model is what we use to define a target for the quantity of testing we should do. Our models help us, if they are graphical in particular, to identify things, to count them and set that number as our target and trace progress towards that target as we create tests to cover the items on our model. Now, if our model is a list, we can still use it as a checklist and count things, but we can't really identify a sensible coverage target for a list that could be endless. And it's got to end somewhere, so that's a subjective kind of idea. So lists are very helpful, but not necessarily useful to define a coverage target. Now, preparing tests might be a very labour-intensive activity. So it could be on a large system where we want to do some end-to-end testing, let's call it. There might be mountains of data that have to be created in the database to facilitate tests that have meaning. This could take days or weeks or months, I've seen. But we always need data of some form. Sometimes the data just has to be dreamed up in our heads and we can do things on the fly. But there's a whole range of activities associated with preparing tests before we actually can run them. Now, when we select things to test, you might call that the process of test design, we often see problems in our sources, and I've mentioned this before. Scenarios aren't well defined, but also when we start to actually test, we discover ambiguities in the requirements, but also we see conflicts and failures in the actual system under test. So we have to figure out, is this a problem of a requirement or is this a problem of the implementation of the system itself? This is part of the skill of and the judgment of the tester themselves. Now, when we run a test, we might get the behaviour we expect, and in some respects that kind of confirms our understanding of the system behaving the way it should do for its users. But occasionally we get anomalies, failures as well. And we either get a confirmation or we get a failure. In either case, we get an increase in our knowledge of what the system does or maybe does not do. Now, confirmations increase our confidence that the system is doing more of what is required, and failures undermine that confidence, but the value of discovering anomalies in the system itself is that we can fix them and improve the system overall. So we communicate failures to developers and ask them to consider what the problem is, to debug it and to fix it. So what is testing after all that long-winded discussion? Our testing stakeholders need information or evidence to make decisions. So testing provides that evidence. So you could look at testing as an information provision service. Now, initially, when we explore our sources, we provide feedback to our sources because we spot anomalies, because thinking seriously about testing, we tend to encounter gaps in requirements, ambiguities in requirements, and so on. So we add value in our projects by looking seriously at our sources of knowledge and finding problems there. So testing prevents defects as well as demonstrating failures which can be diagnosed to a defect. Now, Later on, we expose failures, of course. That's what happens later on when we get our hands on the system under test and really give it a hard time, let's say. So when we experience failures, we share that evidence with developers who have to diagnose and fix defects if they turn out to be defects. We retest those fixes to make sure the fixes work correctly. But we also retest other parts of the system, maybe the whole system at times, to make sure we haven't broken anything in changing components to correct failures. But ultimately, we provide evidence that the system meets in some way the requirements of our stakeholders. And ultimately, we want to hand over a set of evidence which gives them confidence that they're getting what they asked for, if you like. Now, those stakeholders could be the developers, the users, leadership of the project, a whole range of possibilities there, of people who have to make decisions based on the outcome of testing, on the evidence of testing. Now, what we do with that evidence in terms of decision making might be to diagnose and fix a bug. It might be to accept the system as a whole. It might be to reject it, to postpone acceptance, if you like. Or it might be to improve the system. And often we have to take time out to improve the system. Now, that might be scheduled in our project plan, but it might also cause a delay in our projects. So testing often, when we provides evidence that we learn what the system can and cannot do, and we have to change our project plans to suit. So here it is. Testing includes all of the activities to deliver information for stakeholders to make better decisions.